Hello and welcome. Today I'm going to discuss about correlation. Correlation is one of the very important topic as far as research is concerned, and for MBA students also correlation is very much important. So what is correlation? Correlation talks about strength between two different variables. So how the variables are associated, the association and the strength, these two things we can find out by correlation. So correlation we are going to find out by two different methods. Right now I'm going to talk about Karl's Pearson coefficient of correlation. So what is Pearson correlation coefficient? This was given by or developed by Karl Pearson in during 18th to 19th century. He was a statistician, and in correlation, he described the strength and direction of a linear relationship between two different variables. The coefficient of correlation is denoted by a symbol called R. Take one example. If the price of any product is increased, what is going to happen? The chances are there that the demand for that product is going to get decreased. It means when price is increasing, demand is decreasing. So when one value is going to get increased, another one is going to get decreased. Let me give you another example. When you spend more time for study, your marks is going to be what? More or less? It is going to be more. So more time you are going to study, more marks you are going to get. So this is the association. That's what we are talking about. And there is relationship between these two variables. So what correlation talks about? It measures the degree of relatedness between these two variables. How strong or how weak these relationship is there, that's what we measure by correlation. So as I told, correlation, how we denote? We denote correlation by what? The word R. This is R is known as what? Coefficient of correlation. This is coefficient of correlation, right? Correlation. Now, few things which you need to understand before solving the problem of coefficient of correlation by Karl-Pearson method. Whenever we calculate the value of R, the value of R we are going to get always between +1 to -1. So let me draw one line in between. This is what? 0. So value of R, this side +1 and this side -1. So always value of R is in this range. Either you are going to get any value up to +1 till -1. Now, how we will, so this what we are talking here, ranges between -1 to +1. So you can get any values between -1 to +1. So when we calculate and we are getting some value, say we are getting value of R, say equal to 0 point positive, I'm talking about 68. So how to interpret this value? Or say R, we are going to get say -269. How to interpret this value? So interpretation of coefficient of correlation, that is R, is very much important. So see here, let me change the color of this pen so that I can show it to you. 1 second. Till here, say 0.25. This is what? 0.25. Positive also. Negate this side, it is going to be negative. 0.25, 0.5, 0.7. So the values ranges between this what? 0.7. Let me make this 0.5. This is also 0.5, not 25. So if your value is 0 till 0.5, okay, 0 to 0.5, positive or negative, whatever you are getting, it is known as weak correlation. Weak correlation. 0 to 0.5 is what? Weak correlation. 0.5 0.5 to 0.7. 0.7 is moderate, moderate correlation. And zero point 0.7 and above, greater than equal to zero point 0.7 till 1 is known as what? Strong correlation. So whatever value of R you are going to get, if the value is between 0 to 0.5, we will say the correlation is weak. If value of R we are going to get between means zero point 0.5 to zero point 0.7, we will say the correlation is moderate, and zero point 0.7 and above if you are going to get, we will say the strong correlation. Now if it is negative value is coming, you will say negative correlation, and if it is positive, we will say it is positive correlation. So based on value of R, we are going to say whether the relationship is what? Weak, moderate, or strong. So again, remember 0 till 0.5, 0.5 to 0.7, and 0.7 till what? 1. Positive or negative, whatever is coming. If it is positive, you say positive, weak, moderate, or strong. If the value is negative, you say negative, weak correlation, or negative, moderate correlation, or negative, strong correlation. That is how you are going to talk about these things. So hope that makes clear to all of you. Now let us move to the next concept. So yeah, whenever we are going to get a pair of data sets, scatter plot is the first thing which tells us is there any association between the variables or not. Fine. So as we discussed, what is correlation? Correlation measures both the strength and direction of the relationship between variable x and y. So if you see this figure, here you can see when x is increasing, y is also increasing. In another one, you can see when y is increasing, when y is increasing, x is decreasing, and vice versa. So this type of say what let me take the pointer. Yeah, when x is increasing, y is also increasing, and you can see the graph goes something like this side. So this is what? Positive correlation. If you check another one, this is negative correlation. This side, all the variables is going here and there, so no correlation, and this is known as non-linear correlation. So at the beginning, we check by scatter plot. If it has been asked, you draw the scatter plot between a given pair of variable and try to understand how the relationship is. One more thing, if these dots are going like this from this direction to this direction, like how right now it is going, but this is not very close. If it is very much scattered, like dots are coming this side and very much scattered other side, very much scattered, then the what is going to happen? Then you can say that correlation is positive, but what? It is not strong, it is moderate. More distance or more scattered it is, you can say the weaker the correlation, and more closer to the line, stronger the correlation, whether this is positive, this is negative, fine, and this is no correlation. So now let us go to a problem which we are going to solve and understand how we can solve it. So we have been given data for 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. For 8 different years, we have got the data. Okay. For 8 years, we have got the data points, and we have got index of population and number of unemployed. And we are required to find out Karl's Pearson coefficient of correlation for this given data, right? So we need to know the formula. So the index of population we will take as X, index of unemployed we are going to take as Y. So if you want to solve with me, I want you to take a screenshot of this screen, or click it in your mobile so that while working you will be able to do with me, or pause the screen and work on it. So here is the question. I'm giving you time so that you can click this screen and keep with you, and we will be going to solve it. In the meantime, I'm going to write here formula for R. So formula for R is R equal to summation xy divided by summation x square into summation y square and under root this. Okay, so this is the formula by which we are going to solve it. There are many formula, but this is very easy to remember, and we will be able to solve coefficient of correlation by Karl's Pearson method very easily, where capital X equal to what? X minus x bar, x minus x bar, capital Y equal to y minus y bar. What is x bar and y bar? X bar is mean of x. It is what? Mean of x. And what is y bar? Y bar is mean of y. So let us go to the next slide and we are going to solve it. So I have typed all this formula over here. Index of population, number of unemployed. So we will consider index of population as x. Let me change color so that you can see it clearly. It is going to be black. I think that will be visible properly. So this we will treat as x. This is y. So we need to find out capital X. Capital X equal to x minus x bar. Capital Y equal to y minus y bar. So we need x, we need y, we need x square, that is capital X square, we need capital Y square, and we need xy. We need what? Xy. So if you see your formula, the R value, I will write it somewhere here. Let me write, and then later on I will remove it. R equal to what? Summation xy divided by summation x square summation y square under root. This was the formula which I wrote, right? Okay, so we are going to add all these values of x so that we are going to get the mean of x. So what we are going to find out here? We are going to find out mean summation of x, right? So let me add it. 100 plus 102 plus 104 plus 107 plus 105 plus 112 plus 103 plus 99. Yeah. So if we are going to add everything, we are going to get 832. Let me write it here. We are going to get, you can calculate using your calculator. What we got? 832. I'm going to erase this now, the formula which I wrote here, and then I'll write it this place. Eraser, yeah. And next we need summation of y. Hope you are doing summation of y in the meantime. Pen. So here what I need? Summation of y equal to. So if we add, we're going to add 15 plus 12 plus 13 plus 11 plus 12 plus 12 plus 19 plus 26. We will get 120. So this is what? 120. So 1, 2, 3, 4, 5, 6, 7, 8. In order to get x bar, x bar equal to what? So the value of x bar and y bar we have to find out. Y bar 120 by 8, and this is 832 by 8. 832 by 8. If we divide it, we are going to get value of x bar as 104. So here I am writing 104. X bar, that is mean of x, is going to be what? X bar. X bar equal to, we got 104, and y bar 120 by 8, we are going to get what? 15. Now what we need to do? 100 minus 104. X minus x bar. So what is x? X is 100. 100. What is x bar? Minus 104. 102 minus 104. 104 minus 104. This is 107. 107 minus 104. 105 minus 104. 112 minus 104. 103 minus 104. This is 104. Yeah. 99 minus 104. So write all the values. In the same way, if we will calculate value of y, we got y bar equal to 15, and 15 minus 15, 0, 12 minus 15 minus 3, 13 minus 15 minus 2, 11 minus 15 minus 4, 12 minus 15 minus 3, 12 minus 15 minus 3, 19 minus 15, 4, and 26 minus 15, 11. Now, what we need to do? We need to take x square and y square and xy. You can refer the formula which I wrote a little while. So 4 into 4, 16, 2 into 2, 4, 0, 3 into 3, 9, 1 into 1, 1, 8, 8 jar 64, 1, and 5, 5 jar 25. In the same way, we have to take y square. 0 is 0, 3 3s are 9, 2 2s are 4, 4 4s are 16, 3 3s are 9, 9, 16, and 11 11s are 1 2 1. We need summation of x square, summation of y square. So summation of x square, if we will add all these values, we will get 1 2 0. And if we will add all y square, summation of y square, we are going to get 194. 194. Next, we have to multiply x with y. X into y, capital X and capital Y. 4 into 0, 0, 3 into 2, 6. So this 4, this with this we have to multiply, right? These two numbers, x into y. Fine. So 4 into 0, 0, minus 3 into minus 2, going to be 6. 2 into 0, 0. 4 into 3 is going to be 12. 4 into 3 is going to be minus 12. is going to be minus 12. This is going to be 3 into 1 minus 3, 8 into 3 minus 24, 4 into 1 minus 4, 11 into 5, 55, my sign minus 55. So 55, 4 and all those things, if summation x, y we are going to do, we are going to get what? Minus 92, minus 92. Now we got everything. We are going to put these values to calculate value of R. Fine. So we will calculate value of R and we will say that what we are going to get value of R as answer. So let me draw something here. Yeah. So I will go to another slide and I will write formula and we'll put everything into the formula, right? We are going to put everything in our formula. R equal to summation xy divided by summation x square, summation y square. We'll put everything in this formula. Summation xy we got how much? Minus 92 divided by summation x square we have got 120. Summation y square we had got how much? 194 under root. So if you solve it, we are going to get value 0.61. So whether it is strong, moderate, or weak correlation, what do you think? First, there is positive sign, so it is positive correlation. That's for sure. This is positive correlation, right? Now, next what? What I told, if value of R is 0 to 0.5, it is what? Weak correlation. 0.5 to 0.7. What I told, moderate correlation, moderate. M-O-D-E-R-A-T-E, M-O-D-E-R-A-T-E, moderate correlation. Fine. And 0.7 and above. What I told, strong correlation. Fine. So based on our value, what do you think? Can you interpret it? So between index of production, there is, so this is interpretation I'm writing, okay? I'm writing interpretation. There is moderate positive correlation. Correlation between, we had what? Index of production and what? Number of unemployed. Number of unemployed. This is how we are going to write the interpretation. And after solving, you have to write the interpretation based on these values. If it is positive value, positive, it is negative, you have to say there is a negative correlation, but right now we got what? Positive correlation. So we will say there is moderate positive correlation between index of production and number of unemployed. Hope you have understood it. In the next video, I am going to talk about Spearman's rank correlation. So don't miss, watch that video to learn how to solve problem related to what? Spearman's rank correlation. Fine. So thank you and happy learning. Hope you have understood the concept and you will be able to work on these problems.